Welcome to the deep dive. Today we're diving into the world of AI chips.
Oh, yeah.
This tiny world that's kind of quietly shaping everything around us. And our guides for this deep dive are Chris Miller's book, Chip War, The Fight for the World's Most Critical Technology,
Yeah.
and a few other fascinating sources.
It's funny.
Yeah.
Most of us don't think twice about the chips in our devices. But they're not just
Right.
some inert pieces of silicon. They are the brains behind our digital lives.
Yeah.
Everything from smartphones and laptops to smart refrigerators and self-driving cars
Mm-hmm.
all rely on these tiny marvels of engineering.
Yeah,
Yeah,
it's mind-blowing when you think about it.
it is.
I was reading in Miller's book that it's actually easier to build a nuclear bomb
Right.
than a modern ship.
That's a pretty startling comparison, isn't it?
Yeah.
But it really drives home the point that creating a chip with billions of transistors
Right.
packed onto a slipper of silicon smaller than your fingernail
Yeah.
and keeping it affordable is an incredible feat
Yeah.
of human ingenuity.
So, okay, let's rewind a bit. For our listener, can you break down exactly what a chip is
Sure.
and why it's so crucial in the grand scheme of things?
Imagine a tiny city bustling with activity.
Okay.
That's essentially what a chip is. But instead of buildings and streets,
Okay.
it has billions of microscopic switches called transistors.
Okay.
These transistors flip on and off, creating the ones and zeros
Right.
that form the language of computers.
So basically, our entire digital world, all the information, the calculations, the cat videos,
Hmm?
all boil down to these tiny switches flipping on and off.
Exactly. It's a symphony of electrical signals,
Wow.
orchestrated by these transistors that power everything from simple calculations to complex simulations.
Yeah, it's a far cry from those early days of computing when computers used those
Absolutely.
bulky vacuum tubes, right?
Absolutely. Miller mentions a rather amusing anecdote about those vacuum tubes.
Yeah.
Because they emitted light, they used to attract moths,
Oh.
leading to frequent debugging sessions where technicians would have to literally remove moths from the computers.
Oh, wow.
Yeah,
That paints quite a picture. It's amazing to think how far we've come from those clunky, moth-infested machines to these tiny, incredibly powerful chips.
yeah.
So how did this incredible leap in technology come about?
That brings us to Moore's Law,
Okay.
a prediction made by Gordon Moore,
Okay.
the co-founder of Intel, back in 1965.
Okay.
He observed that the number of transistors on a chip, and therefore its computing power,
Right.
was doubling approximately every 2 years.
So it's not a law of physics like gravity, but more of a self-fulfilling prophecy driven by innovation.
Precisely.
Okay.
The chip industry took Moore's prediction as a challenge, pushing the boundaries of miniaturization and performance
Right.
year after year.
And the results have been extraordinary. Miller highlights this
Yeah,
by saying that if airplanes had improved at the same rate as chips,
right.
we'd be traveling faster than the speed of light.
It's a mind-boggling rate of progress. To put it into perspective,
Yeah.
the transistors in today's chips are smaller than a virus.
Wow.
It's a world of miniaturization that we can barely even fathom.
Yeah, it's incredible. Making these chips
Is.
is a complex process, right?
It is.
It's not something one company can do all on its own.
You're absolutely right. The global chip-making ecosystem is a complex web
Right.
of specialized companies and resources from around the world.
Yeah.
The U.S., Taiwan, Korea, Japan, the Netherlands,
Mm-hmm.
they all play critical roles.
And that reliance on so many different players makes this ecosystem quite vulnerable, doesn't it?
It does.
Think back to the chip shortages during the pandemic.
That was just a glimpse of what could happen.
Right.
What if a major natural disaster or political conflict were to disrupt the flow of chips
Right.
from one of these key players? The impact on the global economy would be immense.
And that brings us to TSMC, the Taiwan Semiconductor Manufacturing Company,
Yes.
which plays a particularly crucial role in this ecosystem.
TSMC is a fascinating case, isn't it?
Yeah.
It's the world's largest contract chip maker,
Okay.
producing the majority of the world's most advanced chips,
Right.
the ones that power our smartphones, laptops,
Mm-hmm.
and even the latest AI systems.
But there's a geopolitical dimension to TSMC as well.
There is.
Being located in Taiwan puts them right in the middle of tensions between China and the U.S.
Exactly. Miller makes it very clear in his book that if TSMC's chip production were to be disrupted,
Right.
it wouldn't just be a technological setback,
Mm-hmm.
it would send shockwaves throughout the global economy and could even escalate geopolitical tensions.
So we've got this delicate global balancing act going
You
on
do?
with these incredibly sophisticated chips.
Yes.
And then AI comes along and throws another wrench in the work.
Right.
How has the rise of AI impacted the demand for chips?
The AI revolution is adding fuel to the fire, so to speak.
Okay.
Large language models like ChatGPT require immense computing power
Right.
for training and operation,
Right.
and that's driving demand for even more powerful and specialized chips.
It's like an arms race for computing power with AI pushing the boundaries of what's possible.
That's a great way to put it.
Yeah.
And this demand is not just coming from research labs and tech giants,
Right.
it's spreading across industries.
Yeah.
As companies realize the potential of AI to transform their operations.
This AI gold rush must be driving up the cost of these chips, right?
Absolutely, training these advanced AI models can cost millions, even billions of dollars,
Wow.
with a significant chunk of that budget going towards purchasing high-end chips,
Right.
particularly from companies like NVIDIA, which are currently dominating the AI chip market.
So we've got this incredible demand for AI chips, but they're so expensive. Is this just the reality we're going to have to live with? AI is powerful, but only the big players can afford it.
Well, there's certainly a push to make AI more accessible and affordable, so it's not just limited to those with the deepest pockets.
Right.
The goal is to democratize AI, making it available to smaller businesses, startups, and even individuals.
Okay, that makes sense. But how do you actually go about making these powerful AI chips more affordable?
Well, one approach is to move away from the one-size-fits-all model of chip design. Right now, companies like NVIDIA make powerful general-purpose chips that can handle a wide range of AI tasks. But what if you could design a chip specifically for a particular AI model or application?
So it'd be like having a custom tailored suit, a perfect fit for the job at hand.
Exactly. Specialized chips can offer significant advantages in terms of performance and efficiency, which ultimately translates to lower costs. And we're seeing a lot of innovative startups emerge in this space,
Oh, okay.
developing chips that are optimized for specific AI tasks like natural language processing or computer vision.
So it's not just the big players like NVIDIA anymore. There's a whole ecosystem of smaller companies coming up with new and creative ways to design AI chips.
Absolutely. It's a very dynamic landscape with a lot of competition and innovation. And it's not just startups. The big tech companies are also investing heavily in specialized AI chip design.
Really? So companies like Google and Facebook are making their own AI chips.
They are. They've realized that they can achieve significant performance and efficiency gains by designing chips that are specifically tailored to the AI workloads running in their massive data centers. It allows them to optimize their infrastructure for their specific needs and potentially even leapfrog the capabilities of general-purpose chips.
So this race for AI dominance is pushing innovation in chip design on multiple fronts. But where does it all lead? What's the future of this AI chip revolution?
Well, on one hand, Moore's law, despite all the talk of its demise, is still tugging along.
Yeah,
We can expect to see even more powerful and miniaturized chips in the coming years,
right.
which will further fuel the advancement of AI and other technologies.
And with cheaper and more powerful chips, we'll likely see AI being used in more and more applications, right?
Precisely. AI will become even more pervasive, impacting every aspect of our lives. Think about the potential in healthcare, transportation, manufacturing, education. The possibilities are almost endless.
It's both exciting and a little daunting to think about. This tiny world of chips is having such a profound impact on our lives, shaping the future in ways we can barely even imagine.
It's a reminder that innovation often happens in these seemingly invisible realms, quietly transforming the world around us.
It also underscores the importance of understanding these forces at play, these technological currents that are shaping our present and our future.
Absolutely. As AI becomes more powerful and ubiquitous, it raises important questions about the skills and knowledge that will be most valuable in the future, about the potential economic and societal impacts of widespread automation, and about the ethical considerations of an AI-driven world.
So it's not just about the chips themselves, it's about the larger conversations we need to be having about the role of AI in our lives and in society as a whole.
Exactly. It's about understanding the forces that are shaping our future and being active participants in shaping that future rather than just passive bystanders.
Okay, so we've gone from moth-attracting vacuum tubes to virus-sized transistors, from the intricacies of the global chip-making ecosystem to the geopolitical risks surrounding Taiwan, and now to the future of AI chips and their profound implications for our world. Where do we even begin to unpack all of this for our listener?
Well, I think the most important takeaway is that we're at a pivotal moment in history. The decisions we make today, the investments we prioritize, the conversations we engage in, they will shape the future of AI and its impact on our world.
It's a call to action, isn't it? To be informed, to be engaged, to think critically about the potential benefits and risks of AI, and to work towards a future where this powerful technology is used for good.
Exactly. The future is not preordained. We have the power to shape it, to steer it towards a future that benefits all of humanity.
And understanding the world of AI chips, these tiny but mighty engines of the digital revolution, is a crucial step in that journey. So we've covered a lot of ground in this deep dive. We've explored the incredible journey of chips from their humble beginnings to their current status as the driving force behind the digital revolution. We've also touched upon the geopolitical complexity and the ethical considerations that come with the increasing power and pervasiveness of AI. As we wrap up, what's the key insight you want our listener to take away from all of this?
Well, I think it's important to realize that the world of chips, this seemingly obscure domain of silicon and transistors, is deeply intertwined with our lives, our economies, and even our global security. The decisions made in this world, the innovations that emerge, the competition that unfolds, they all have ripple effects that extend far beyond the realm of technology.
Yeah, it's a reminder that even the smallest things can have a massive impact. Those tiny chips in our pockets, in our homes, in our cars, they're not just passive components, they're shaping the course of history.
And as AI becomes more powerful, more ubiquitous, that impact is only going to amplify. The chips that power AI will determine the pace of its progress, the scope of its applications, and ultimately its influence on our world.
So, what does this mean for our listener? How should they navigate this complex landscape? What should they be thinking about as they interact with their AI powered devices, as they read headlines about the chip war and the AI race?
I'd encourage our listener to approach this topic with a sense of informed curiosity. Stay informed about the latest developments in AI and chip technology, engage in conversations about the ethical implications of AI, and perhaps most importantly, think critically about the potential impact of these technologies on your own life, your work, and your community.
So, it's about being an active participant in shaping the future rather than a passive observer.
Exactly. The future of AI is not predetermined. It's a future we are creating collectively through the choices we make and the actions we take. And understanding the crucial role that chips play in this technological revolution is a vital step in that journey.
Well, thank you for guiding us through this fascinating deep dive into the world of AI chips. It's been an eye-opening exploration, and I'm sure our listener has come away with a new appreciation for the power and the potential of these tiny but mighty pieces of technology.
It's been a pleasure sharing these insights with you and your listeners. And remember, the world of technology is constantly evolving. So keep exploring, keep learning, and keep asking questions.
Thanks for tuning into the deep dive. See you next time. TCEOS.